Alright, today is November 17th, and we are factoring with special cases, which is one of my favorite topics. So we have three different special cases to work with. We have the difference of squares, the sum of cubes, and the difference of cubes. So these are formulas that you will need to know, you will most likely be given, but you do need to know how to use them. So if we have the difference of squares, we have a squared minus b squared, where a squared and b squared are perfect squares. They have to be perfect squares. It can't be like the square root of 15. It can't be anything like that. It needs to be something that you can take a clean square root of and it's going to work perfectly. So the difference of squares, when we factor it, it is a plus b times a minus b. So the only difference between the two sets of parentheses is that one is a plus and one is a minus. So the difference of squares is going to be the easiest one that we work with. On 21, says x squared minus 4. I gotta check, is x squared a perfect square? And it is. It gives me x. And is 4 a perfect square? It is. I get 2. So when I'm writing my factors out, it's going to be x plus 2, x minus 2, and that's it. I'm done. And so I am going to show you why that works. So if I had x plus 2 times x minus 2, I would FOIL this out. And I would have x times x, which is x squared, x times negative 2, which is negative 2x, and then 2 times x and 2 times negative 4, so plus 2x minus 4. 2x minus 2x, those two in the middle will cancel. So x squared minus 4, it works. So with the difference of squares, again, we're just going to take the square root of both and then put those into parentheses with plus and minus in between. So 22, we're going to take the square root of y squared, which is y, and the square root of 81, which is 9. Y plus 9, y minus 9. I'm done. Now let's look at 23. It's a little more difficult. We're taking the square root of the first term, so 9x squared. So we'll take the square root of 9, which is 3, and the square root of x squared, which is x. Same thing with the second term, 25 y to the fourth. Square root of 25 is 5. Square root of y to the fourth is y squared. So I have 3x plus 5y squared times 3x minus 5y squared. Then on number 24, m squared n squared minus 49. Square root of the first term, so square root of m squared n squared. It's going to be m times n. Square root of 49 is 7. So we have m n plus 7, m n minus 7. So like I said, the difference of squares will be the easiest special case to work with because we just find the square root of both terms. You do have to be able to tell, though, if it is a difference of squares. So you do have to know your perfect squares and know, can I take the square root of these? Sum of cubes. So you see we jump straight into cubes and we don't go into the sum of squares. You cannot factor the sum of squares with a special case formula. You cannot do it. It will not work. So just be aware of that. The sum of squares is not a thing. Difference of squares, yes. Sum of cubes, yes. So the sum and difference of cubes are a little trickier because they have more details to them. So on the sum of cubes and the difference of cubes, I'm going to try to show you the way that I remember. So if we have perfect cubes, so the same way we had to have perfect squares, we have to have perfect cubes. If we have perfect cubes on both terms, we're going to do same sign, opposite, always plus. So if you look at the difference of cubes, it's same sign, opposite, always plus. So that's the way that you can remember what the signs are, just because I think that might be the most difficult part of remembering the formulas. So same, opposite, always. So it's going to be the same as what you start with, the opposite of what you start with, and then always plus on the end. So on example 3, we have a plus. So this is going to be a sum of cubes. Since these are examples, you will know that they are cubes, but on problems where it's just as factory, you wouldn't know that. So a key to knowing if you're dealing with a special case is if you have two terms and then you have a cube in the front. So I'm going to take the cube root of x cubed, which just like a square root on a square, it's going to cancel it out, and I get x. And then I'm going to take the cube root of 27, and I get 3. If you don't know what those are, that's okay. You can find the cube root with any calculator. So we have x and 3 as my a and my b. So then I'll plug those into the formula. Same sign, x plus 3, square the first term, x squared, opposite sign, squish them together, 3x, and then always square the last term, 9. On a problem that said factor completely, be aware that you would have to check, can I factor this further? On the problem we're doing right now, we're just finding the factors given the formulas, so it's okay to stop there. Then on practice 3, the same type of problem. It's a cube with two terms, so we're going to take the cube root of each. Cube root of x cubed is x. Cube root of 216, I want to say is 4, but I'm probably way off. Yeah, 4 is 64, so it's going to be 8 maybe? Let's check. It's 6, I was way off. So the cube root of 216 is 6. So again, if you don't know, that's okay. I didn't know what the cube root of 216 was. But the more practice we get on these types of problems, it's going to get quicker and quicker and quicker, and then you're going to know these numbers off the top of your head. But again, that's going to take practice on your end. And so if you are not putting the practice in, then of course you will be struggling with finding what these numbers are. So I haven't done this in a year, so I don't know what 216 is off the top of my head, and that's okay. So we found our a and our b. This is a minus, so be careful. We're going to take the same sign. So x minus 6, square the first term, squish them together with the opposite sign, so plus 6x, always plus, square the last term, 36. On example 4, we have 8x cubed minus 125. This cube with two terms is my key that it might be a sum or difference of cubes. It is possible that it would not work. Since these are examples, we are assuming that it will. So we're going to take the cube root of both terms, 8x cubed. The cube root of 8 is 2. and then the cube root of x cubed is x. And when I say cube root, I mean what times itself 3 times gives me that number. So for 8, 2 times 2 times 2 gives me 8. 2 times 2 is 4, times another 2 is 8. And we'll do the same thing with 125. Cube root of 125 is 5. So this is my A, and this is my B. And so we'll plug that in. We've got 2x, same sign, minus 5. Square the first term, so square 2. We get 4. Square x, we get x squared. Then we're going to squish them together with the opposite sign. 2x times 5 is 10x. And then square the last term always with a plus on it, plus 25. Again, with these sum and difference of cubes, you will have to be careful in the future when it says factor completely, just to make sure that the second factor cannot factor any further. Then for practice 4, we have 2 terms and a cube, so we're going to assume that this is a sum of cubes. We're going to take the cube root of each. If you start by assuming and then you find out that it is not a cube, so let's say that we got like 7.5 or something, then we wouldn't be able to continue with this formula. If you find a cube root and it is a good clean number like 7, then you can continue on. Cube root of 1000, I want to say is 10. Yeah. So 7x is my A, 10 is my B. So first term minus the second term, since they start with a plus. Oh, I'm so sorry. Same sign, then opposite. So we're going to square the first term, 49x squared. Opposite sign, that's where the minus goes. Squish them together, 7x times 10 is 70x. Square the last term, always a plus, plus 100. So then the next page is for you to do for homework. Again, I will post I'll post half of them. So half of the answers will be posted so that you can check whether your answers are right or not. So check back in a little bit. For the answers on half of them. Make sure that you get this completed and that you submit it on Canvas.